is like a linear function. It has a common difference between the terms. So like linear function, it has a common difference between terms. Can you see the red, or should I change color? Maybe I can change color. So D is that common difference. It's basically your rate of change. So D is your common difference. So in the homework and stuff, it's going to say find D. So D is always the common difference there. Now I'm not by the glare. So you're going to need to know the closed formula, because when we get to series, you're going to have to be able to write the formulas without looking them up every time. So it's not that hard. It's basically like y equals mx plus b, but they write it in a slightly different order. So a sub n equals, it's basically your starting term plus your common difference n minus 1 times. So a sub 1 represents what you started with, and then the common difference is how many times you need to add 3, or how many times you need to add 7. A sub 1, yep, so it's basically representing your starting term plus the common difference. This is a D. And then this is not a subscript. This is n minus 1 as a multiplier. So if I skip for now recursive and I just go down to this example, let's write the closed formula for this example. So I know that it's arithmetic because it's going up by a constant amount each time. It's going up by 5, plus 5, plus 5. Oh, it's going down by 5. Minus 5, minus 5, minus 5. So my closed formula for this is going to be a sub n equals my starting term, which was 4, minus 5 n minus 1 times. So the nice thing about your closed formula is it allows you to do this. It says use the closed formula to find a sub 15. So I can find the 15th term just by plugging in 15 for n. So I would have 4 minus 5 times 14, right? If I start at 4, I'm going to subtract 5 14 more times. 4 minus 5 times 14, that will just produce the output value. Recursive, you'd have to find all of the preceding terms. So this tells me that my 15th term is negative 66. So the recursive formula is a little bit different. So the recursive formula, I'm going to use a sub k, but you could also use a sub n. So I'm going to say, how do I find the term I want, a sub k? I take the term that comes before it, so a sub k minus 1, and I add my common difference. And then I need to tell the reader what a sub 1 is as part of my formula. So a sub k equals a sub k minus 1 plus your common difference. So what are you adding every time? And you need to tell them where to start. So if I write the recursive formula down here for this example, it's got some things are going to look the same and some things are going to look different. So the recursive formula, a sub k equals a sub k minus 1 minus 5, right? Because our common difference was minus 5. I'm subtracting 5 every time. And I need to tell them that a sub 1 is 4. So this whole thing is the recursive formula. So it tells you what to do. Start at 4 and subtract 5 every time. The reason the closed formula is better is you can plug in 15 and get an answer. Over here, you can't plug in 15. You would basically have to start at 4 and subtract 5, subtract 5, subtract 5, subtract 5, all the way till you've done it 15 times. So closed formula is more efficient because you can plug n into the closed formula. So we're going to be using closed most of the time, but I do want you to know about recursive too. So these are the types of examples you'll see on your homework. It'll say, first find the common difference, and then write the closed formula. On your homework, it'll say find, A sub n. A sub n means find the closed formula for the nth term, and use it to find A sub 8. So let's do 7 together, or number 2 together, and then you try number 3. So I'm going to write out my closed formula after I find D. So what's my common difference this time? 4, right? I'm adding 4 every time. So A sub n, so I'm starting at 7 and I'm adding 4 n minus 1 times. So every time, that's how you write a closed formula. It's your starting term, what you're adding or subtracting, n minus 1 times. Because you don't want to subtract it on the first term. So when you plug in 1, see how you get 7 back? But then when you plug in 2, you get 7 plus 4, which is 11. So then generate A sub 8. So when you plug in 8, what do you get? So 7 plus 4 times 7. So 28 plus 7 is 35? Yep. All right, so you do example 3, and then we're going to do some problem solving down below with arithmetic sequences. So for the sake of my video, so A sub n is 2, and I'm subtracting 5 n minus 1 times. So when I want to generate the 8th term, I'm doing 2 minus 5 times 7. So 2 minus 35 is what, negative 33? Is that what you got? Okay. So these are all linear functions, right? Constant rates of change. So every time they're going to tell you now, okay, we're dealing with arithmetic sequences. So this says, let's find the closed formula if we have an arithmetic sequence. They're giving you the 4th term and they're giving you the 13th term. And you have to find the closed formula to generate the 20th term. So you're going to have to do some problem solving. So what I do is I write out for myself that the 4th term is 20, and then I go up to the 13th term, and that's 65. How many terms did I go up, and how much did I add total? What? So see how your brain can kind of see it? So there were 9 terms, right? 4 plus 9 is 13. So there were 9 terms, and I went up by 45. So what's my common difference? 45 divided by 9 is 5. So now that I know my common difference, I also need to find the first term. So you could either subtract or just kind of draw your pattern backwards, like this would be 15 and then 10 and then 5, right? So my A sub 1 is 5, and my common difference is also 5. So maybe you could see that. So then we're going to write our formula. There's actually 2 different ways to write this formula. So if we just want to follow what we did up top, A sub n is 5, and we're adding 5 n minus 1 times. Sorry, it kind of jammed in there. That's the same as just saying 5n. Because if your starting term and your difference are the same, see how this would just give me 5n right here minus 5 when I distribute. So these are the same equation, and it's just, if you see that this is just 5 times 1, 5 times 2, 5 times 3, 5 times 4, 5 times 5, I like using this second equation better myself, but this is that the same pattern holds. There's your first term, there's your common difference, n minus 1 times. So when you plug in the 20th term, 5 times 20 is 100. So A sub 20 is 100 was their final thing they wanted you to do. So that was a long problem. I should have given you a little bit more room for that. All right, I'd like you to use problem solving and try 5 and 6 on your own. Well, where did we get stuck on number 5? So The second term, oops, I shouldn't have written it there. So the second term is 8. The 12th term is 28. So I have 10 terms and I'm going up by 20. So my common difference is 2, right? 20 divided by 10. So if that's the second term, all I have to do is go backwards by 2, right? So my first term would be 6, 6, 8, 10, 12, 14. Oops. Is that right? Because I'm starting at 6 and I'm adding 2 every time, and they want you to write the recursive formula. A sub k equals a sub k minus 1 plus 2, a sub 1 equals 6. I didn't write it very well, but that's really hard. Full 6. Are you going to write the formula and then see if you can produce 82 or not by guess and check? Or you could also look at the table on the calculator. You could also, type it in with x instead of n and then see if 82 pops up and what term it is. You could also solve it like a linear equation, like try to get x by itself equals to 82. Did you figure it out? A sub n equals 6 plus 4 times n minus 1. So what I would do, I would plug 82 in as the output, 6 plus 4 times n minus 1, and solve for n. And if n comes out as an integer, that's the term number. If n doesn't come out as an integer, it's not the term number. So I would take 82, subtract 6, divide by 4. 82 minus 6 divided by 4. So I get 19 equals n minus 1. So n would be 20. So yes, and n is 20. And you could also do that by guess and check. So you could keep plugging in numbers here for n until you get 82. And obviously, if n is not an integer, it does not fall in the sequence. All right. So the back page, it has some guided practice, but before I send you on your way 1 through 6, I'd like to look at 7 and 8 together, just because these are basically linear functions, but they're applications of these arithmetic sequences. So let's just see if we can answer 7 and 8 together first, and then have you jump back to 1 through 6. So Jamie enjoys getting a consistent hourly raise of 75 cents per hour every 6 months. At Nike, he's worked at Nike for 2.5 years, just received his hourly raise. So he's currently making $18 per hour. What was his starting hourly wage? So you could go backwards using a formula. You could just kind of, to me, this is tricky because you have to think about how many 75-cent raises he's received. So he's currently at 18, and 2.5 years, how many raises has he received? Right? He gets a raise every 6 months. So how many raises did he get? 5, right? So 1, 2, 3, 4. Would that give us the right amount? Here's the start, right? Here's raise number 1, 2, 3, 4, 5, right? So you have to problem solve going backwards those 5. So you could either go back just 5 times 75 cents, or you could actually generate each term backwards. But to me, sometimes it's hard to think about how many steps you've actually walked in the sequence. So real life application, draw something out for yourself. So what would you say the starting wage was? I got $14.25. Hold on, if we do 8, if I go backwards in steps, this would be $17.25, $16.50, $15.75. I think you just didn't do enough. 15 and then $14.25, right? Because this would be after 6 months, 1 year, year and a half, 2 years, 2.5. So $14.25 was the starting value. I don't really, yeah, I don't know. Maybe that's far off. So like, right, so this last one, and then you can try some guided practice. So this says a business did $12,000 in sales on Black Friday in 2016. The owner of the business has set a goal of increasing Black Friday sales by 1,500 each year for 4 years. Assuming this goal is met, what's the sales goal for the next 4 years? And then find the Black Friday sales totals. So totals is leading us towards series. So you actually need to list them out this time. So this would be 2016, 17, 18, 19, 20. So you're going to list out your 5 sales goals and then add them together to get your sum for your Black Friday sales totals for all 5 Black Fridays. So this would be arithmetic. We're listing them out, but when we add them together, we're actually doing a series, which is what we're going to do next week. This is only adding 5 terms together, so you could do it by hand, but we'll learn the shortcut next week to have the calculator do it for us. So calculate your total, and then we're going to jump up to try the guided practice. Finish this so that people who weren't here. Okay. So I start at -9, and then I get to -6, so I go up by 3. So a sub n is -9 plus 3 and minus 1 times. And then this one, the common difference is 5. The first term is 7, so 7 plus 5 and minus 1 times. And then on number 3, common difference is -2, and my second term is 0. So I must have like that, right? I start at 2, go down by 2. So a sub n equals 2 minus 2 and minus 1 times. Generating 4 terms, so I'm just going to plug in 1. So I'd get 0, so I get 2. When I plug in 2, 2 plus 7 is 9, and then I'm going up by 7 each time. And then generating the 4 terms of the sequence, I'm going to plug in 1, so I'd get 0. When I plug in 2, I get -3. When I plug in 3, I get -6, so I'm going down by -3 each time. And then this is recursive, so I'm starting at -7, and then I'm adding 8 each time after that. So 1, 9, 17. And then we said the last question was 75,000.